In 2024, a controversial study suggested that one single stone pillar, buried in the hills of southeastern Turkey, contained something far more profound than anyone had expected. A message so precise, so mathematically deliberate, that it would force scientists to rewrite what they thought they knew about human capability 12,000 years ago. Here's the twist. Almost nobody talking about this online will tell you, honestly. There was no artificial intelligence involved in this discovery, no neural network, no machine learning model, no secret algorithm quietly decoding ancient symbols while researchers watched in disbelief. What actually happened is stranger, and in its own way, far more impressive than any AI headline could capture. A single human mind, armed with nothing but mathematics, statistics, and an enormous amount of patience, may have uncovered evidence that people living at the very edge of the last ice age understood the night sky with a level of precision we're only now willing to take seriously. This is that real story, the one that got buried under a wave of viral videos claiming a computer cracked an ancient code. It's a story about real science, a real researcher, and a monument that keeps forcing archaeologists to throw out their assumptions about who our ancestors actually were. Let's start with the site itself, because Göbekli Tepe earns every bit of the astonishment usually reserved for far younger, far more famous monuments. Tucked into the hills of southeastern Turkey, close to the Syrian border, Göbekli Tepe sat buried and forgotten until systematic excavation began in 1996 under German archaeologist Klaus Schmidt. What his team found should not have existed, according to almost everything historians believed about the ancient world at the time. Massive T-shaped limestone pillars, some standing nearly 18 feet tall, some weighing up to 20 tons, arranged in deliberate circular enclosures, carved entirely using flint tools, by hand with no metal, no wheel and no draft animals to help move the stone. Radiocarbon dating places the oldest layers of construction at roughly 11,600 years ago, predating Stonehenge by about 6,000 years, and predating the invention of pottery and the wheel entirely. What made this genuinely staggering to archaeologists wasn't just the age, it was who built it. For most of the 20th century, the accepted timeline of human civilization ran in a strict, orderly sequence. Humans hunted and gathered, then eventually learned to farm. Farming allowed permanent settlement. Settlement produced surplus food. Surplus food allowed specialized labor and social hierarchy. And only then, once all of those pieces were finally in place, did large-scale monument building become possible. Göbekli Tepe broke that sequence completely. The people who built it were still hunter-gatherers. No evidence of farming, no permanent granaries, no clear evidence of centralized rulers commanding a workforce. And yet here was organized, monumental construction requiring coordinated labor across what appears to have been many generations, built by people who, according to the old model, weren't supposed to be capable of anything like this for thousands of years yet. For the first 2 decades of excavation, archaeologists focused on cataloging what they could see plainly. The T-shaped pillars, widely interpreted as stylized human or divine figures, given that some are carved with arms, hands, and belts. Reliefs of animals covering the stone surfaces, foxes, boars, snakes, scorpions, vultures, rendered with genuine artistic skill. Researchers debated whether the site functioned as a temple, a ceremonial gathering place, or something else entirely, since there was no obvious evidence of permanent habitation to compare it against, at least not at first. Then, in 2017, a researcher named Martin Sweatman, an engineer at the University of Edinburgh rather than a traditional archaeologist, approached the carvings from a completely different angle. And that approach is where the real non-AI part of this story actually begins. Sweatman's background was in chemical engineering, not archaeology, but that background gave him a specific set of mathematical and statistical tools that most traditional Egyptologists and archaeologists simply weren't trained to apply. He started asking a genuinely interesting question. What if these animal carvings weren't purely decorative or symbolic in the way scholars had assumed? What if they represented something more specific, constellations, mapped deliberately onto a single pillar, encoding a piece of information the carvers wanted future generations, or future observers, to be able to reconstruct? This wasn't an entirely new idea in the abstract. Archaeoastronomy, the study of how ancient monuments align with or represent celestial events, is a well-established, legitimate field of research, applied seriously to sites like Stonehenge and various Mesoamerican structures for decades. What made Sweatman's approach different was the method. Rather than relying purely on visual interpretation and educated guesswork, the way earlier archaeoastronomy research often did, Sweatman built computational models using historical star charts and astronomical software capable of calculating exactly where constellations would have appeared in the night sky at any specific point across thousands of years of Earth's history. That calculation is possible because of a real, well-understood astronomical phenomenon called axial precession. Earth's axis doesn't point in a perfectly fixed direction. It slowly wobbles, tracing a full circle over a period of roughly 26,000 years. That wobble is far too slow to notice in a single human lifetime, but it gradually shifts which constellations appear in which part of the sky at a given time of year, a shift astronomers today can calculate backward and forward through history with genuine mathematical precision. Using that computational modeling combined with statistical probability analysis, Sweatman examined the carvings on a specific stone at the site known as Pillar 43, located in what archaeologists call Enclosure D. He didn't simply eyeball the carvings and declare a match. He tested the arrangement of animal figures against calculated star positions across a wide range of possible dates, then ran statistical analysis to check whether any apparent match was more likely to be genuine pattern or simple coincidence. His work went through peer review and was published in an academic journal, meaning other qualified researchers had the opportunity to scrutinize his methodology and data before it reached publication. Exactly the process legitimate scientific claims are supposed to go through. His conclusion when it came was specific enough to raise eyebrows across the field. The arrangement of animals on Pillar 43, when interpreted as representing constellations broadly similar in position to ones later catalogued by the ancient Greeks, pointed toward a specific window in time, approximately 10,150 BCE, with an estimated margin of error of around 250 years. That's a remarkably narrow date range to extract from a stone carving nearly 13,000 years old. Why would anyone go to the trouble of encoding a specific date into stone using such an indirect, complicated method? Sweatman's proposed answer connects to something else entirely, a genuinely significant and separately debated hypothesis in climate science called the Younger Dryas impact hypothesis. This hypothesis, which is not universally accepted among climate scientists but has real serious researchers behind it, proposes that around 10,150 BCE, a comet fragmented in Earth's atmosphere, showering debris across large portions of the northern hemisphere. And the proposed consequences were severe: massive wildfires, a sudden injection of dust and ash into the atmosphere, and an abrupt, dramatic return to near ice age conditions that lasted for roughly 1,200 years, a period geologists call the Younger Dryas. Researchers who support this hypothesis point to physical evidence in sediment layers from this period, including elevated concentrations of platinum and microscopic nanodiamonds, materials that are unusual to find in normal terrestrial sediment and are sometimes associated with cosmic impact events. Although it's worth being clear that mainstream climate science remains genuinely divided on how much weight to give this impact hypothesis versus other proposed causes of the Younger Dryas cooling event. This period also happens to line up closely with the extinction of a wide range of large Ice Age mammals, woolly mammoths, saber-toothed cats, giant ground sloths, and it sits right around the same broad window in which agriculture first began emerging in the Fertile Crescent. Sweatman's theory proposes that the people who built Göbekli Tepe either witnessed this catastrophic event directly or inherited detailed knowledge of it through careful oral transmission across generations, and that Pillar 43 functions as a memorial, a deliberately encoded date stamp marking the moment their world changed, carved using the only language durable enough to survive over such an enormous span of time: the stars themselves. This remains, and it's important to say this honestly, a genuinely controversial theory within mainstream archaeology. Many archaeologists remain skeptical, arguing that reading specific constellations into ambiguous animal carvings risks projecting modern patterns onto symbols whose original meaning may have been entirely different, or may never be fully recoverable at all. Human brains are, after all, extraordinarily good at finding patterns, sometimes finding them in places where no real pattern exists, a well-documented cognitive tendency that legitimate researchers have to actively guard against in their own analysis. Sweatman's specific rebuttal to that criticism is that his method isn't based on subjective visual interpretation alone. It's based on statistical testing designed specifically to check whether a proposed pattern is more likely to reflect genuine intentional design or random coincidence. His analysis suggests the odds of the animal arrangement matching this specific astronomical configuration purely by chance are quite low. Whether that statistical argument fully settles the debate is, honestly, still an open, actively discussed question among researchers in the field, not a closed case in either direction. Sweatman didn't stop with the 2017 findings either. In 2024, he published additional research focused on a different set of markings on the same pillar, a series of repeated V-shaped symbols carved across its surface. His analysis proposed that these V-shapes function as counting marks, and that arranged together with other geometric symbols on the pillar, they may represent a lunisolar calendar, a system designed to track both the roughly 365-day solar year and the shorter, roughly 354-day lunar year simultaneously, reconciling the mathematical mismatch between the two by adding extra days, the same basic problem every calendar system in history has had to solve in one way or another. Sweatman's proposed reading involves 12 lunar months plus 11 additional marked days, totaling 364, with the 365th day completing the solar year, represented by a separate symbol on the pillar, possibly a carved disc. If this interpretation holds up under continued scrutiny, and again, it remains a genuinely debated, unsettled proposal rather than an accepted fact, it would represent the oldest known complex calendar system yet identified anywhere in the world, predating the next oldest widely accepted calendar systems by several thousand years. It's worth pausing on why that would matter so much, beyond simple novelty. Building a working calendar isn't a casual creative flourish. It requires sustained, careful observation of celestial cycles across many years, the conceptual ability to treat time itself as something measurable and divisible, and enough continuity across generations for that accumulated observational knowledge to actually get passed down and refined rather than lost. Every calendar system in human history represents a genuine cognitive achievement built on long-term collective knowledge, and finding convincing evidence of this early would meaningfully reshape timelines historians use to describe when abstract mathematical thinking first emerged in human culture. And this is exactly the point in the story where things went sideways online. Once these findings started circulating beyond academic circles, the actual carefully hedged, peer-reviewed research got flattened into something completely different. Viral videos began claiming that artificial intelligence had decoded Göbekli Tepe's symbols, that hidden warnings about future catastrophes had been uncovered, in some cases stretching all the way into claims involving ancient aliens or a lost advanced civilization. None of that reflects what actually happened. There was no algorithm involved. While all of this online distortion was spreading, actual verified archaeological work at the site kept quietly producing discoveries that mattered more than any exaggerated claim ever could. Excavations in 2025 uncovered evidence that seriously complicated the older assumption that Göbekli Tepe functioned purely as an occasional ceremonial gathering site. Archaeologists found grinding stones used for processing food, plant remains, and animal bone fragments, the kind of everyday domestic debris you'd expect from people actually living somewhere, not just visiting periodically for ritual purposes. Alongside this, researchers identified smaller, more practical residential structures distinct from the famous monumental T-pillar enclosures, suggesting the site functioned as a genuine semi-permanent or permanent community where ritual life and ordinary daily life were woven together, rather than existing as two separate categories entirely. Perhaps the most striking single find came in late 2024 and early 2025, when archaeologists uncovered a life-sized human statue at the site, deliberately placed within a wall inside Enclosure D. The statue showed genuine anatomical detail and defined facial features, suggesting an actual attempt at individual portraiture rather than a purely generic or symbolic human form. This was the first statue of its kind found directly at Göbekli Tepe, though a related, even larger example, an 8-foot-tall human statue attached to a stone bench, had previously been discovered at the nearby site of Karahan Tepe, part of a broader cluster of related sites in the region now studied together under a coordinated research initiative called the Taş Tepeler, or Stone Hills project, involving Turkish archaeologists working alongside international collaborators using LiDAR scanning, ground-penetrating radar, and drone photography to map what still lies beneath the surface. That underground picture, it turns out, is enormous. Current estimates suggest only around 10% of Göbekli Tepe has actually been excavated so far. Ground-penetrating radar surveys have detected additional buried stone circles and substantial structures still completely unexplored, with researchers estimating as many as 15 additional enclosures may remain hidden beneath the earth, some potentially dating back as far as 13,000 BCE, which would push the origins of monumental human architecture back even further than currently confirmed. At the current pace of careful, methodical excavation, researchers estimate the site could take well over a century to fully uncover, meaning literally none of the archaeologists working there today will live to see the project completed. So where does that leave the actual, honest answer to the question of what Göbekli Tepe's symbols reveal? Not a hidden AI-cracked code, not a warning from a lost civilization, something quieter and arguably more remarkable, real, working evidence that people living at the tail end of the last ice age, without agriculture, without writing, without any of the institutional scaffolding historians long assumed was required for complex thought, were capable of sustained astronomical observation, abstract mathematical reasoning, and monumental collective effort spanning generations. Whether Pillar 43 turns out to be a memorial to a genuine cosmic catastrophe, the oldest known calendar on Earth, both, or something researchers haven't fully worked out yet, the underlying achievement doesn't depend on any single interpretation landing perfectly. It depends on what these people demonstrably built, with their own hands, using their own minds, 12,000 years before anyone thought that kind of ambition was even possible. The mathematics behind this discovery is more elegant than any AI headline gives it credit for. The human achievement, both the ancient builders who carved these stones and the modern researcher who spent years carefully testing whether the patterns inside them were real, is more genuinely inspiring than any manufactured claim about hidden technology ever could be. Our ancestors weren't primitive. They were patient, observant, and capable of extraordinary things, working entirely within the limits of stone tools and human memory. If uncovering the real story behind the headlines, the one where actual human ingenuity turns out to be more remarkable than the hype, is what you're here for, subscribe, because Göbekli Tepe is still only 10% excavated and there's clearly a lot more waiting underground.